I am E. Krishna Rao Patro, Associate Professor in the Department of CSC, IARE College, Hyderabad. Today, we will discuss about one important sorting, that is Quicksort. Quicksort is one type of divide and conquer algorithm. This algorithm picks an element as a pivot, and based on the pivot element, it will partition the given array. Based upon the value of pivot, it will divide the array into two parts. Actually, there are different ways of choosing the pivot. The pivot element can be a first element. The pivot element can be a last element. The pivot element can be a random element. The pivot element can be a median element also. So, based upon your choice, you can choose any of the element as a pivot. So, based on the pivot, you can start processing. So, that means the pivot element will decide where it has to be fit in the array. So, wherever it find the position, left to this should be less and left to that pivot should be greater. So, that is the policy. Now, see that the key process in Quicksort is first partitioning. How to do partition? There is a process. And after partition, what is the result? The result is all the smaller elements will be left side and all the bigger elements will be right side. So, that is our target. And all should be done in the linear type. So, you must be very careful for this process. This is one of the very, very important process in the Quicksort. Now, you can see, you can select a pivot element, rearrange the list so that all the elements in the positions before the pivot element are smaller than or equal to the pivot, and those are after the pivot should be larger than the pivot. So, exchange the pivot with the last element as the first sublist, then pivot will come to the final position after the sorting. So, you can observe this diagram. The pivot elements P will come to its position. After coming to the position, assume this is the position P. Now, whichever elements come to the left should be less, and whichever elements comes after this should be greater. So, that means in a diagrammatic you can represent this way. So, it says that A of I should be less than P and A of I should be greater than P. So, this is the final result of the partition algorithm. So, you have to write a special procedure to do this. You can estimate a small example how the Quicksort works. Assume there are set of elements like 35, 33, 42, 10, 14, 19, 27, 14, 44, 35 and 31. So, you have chosen the 31 as a pivot. Every time it is checking from left to right as well as right to left. The left side data is always less and right side data is always greater than the pivot. So, in the diagram, you can observe here how the elements are chosen. So, now the C31 has come to the exact position. So, this is the way it works. First, the low start from beginning and the high start from end. So, it is comparing 31 with 26. 26 is less. 33 is but not less. So, stop there. This right side checking. 35 is greater than 35. 44 is greater than 35. 33 is greater than 35. When 19 comes, stop it. So, then it will swap between this low and high. After swapping, again keep on continuing. How long it will continue? Until the high is crossing low. That time, wherever low is there, the pivot element will be swapping. Now, here, the procedure is always keep on checking from left to right as well as right to left. First to left to right, then right to left. Because you have chosen the last element is a pivot. Please observe here the 31 is pivot here. It is checking 26 is less than pivot. 27 is less pivot. 19 is less than pivot. 10 is less than pivot. So, earlier, so based upon the value, it will be changing. You can see the diagram how it is moving. Wherever low and high are there, after one round, the low and high will be interchanging. Okay. So, this is the simple, the representation of this Quicksort process. Now a small algorithm for Quicksort. The Quicksort algorithm will take three parameters. First is the array. This is the array which holds all data. Low is the starting index and high is the ending index. So you will be knowing low index as well as high index of the array because you are arraying set of elements. Now it will check whether low is less than high or not. If it is less than high, then it will try to partition the data for the given data. Now array is having my set of data and low is my low index, high is my high index. If you pass these three, the partition will give the real position for the pivot. So based upon the value of pivot, because after getting the pivot, what it will do? It will divide the list into two parts again. So the first partition will be called with low with -1 and second partition will call j+1 with high. So that means you are passing these two parameters. So you will be passing the lower index as well as partition -1 means j is the partition point. After getting the partition point, you will be making into the list into two parts. So wherever j is there, j is the point for the pivot. So below j will be first part, after j then will be second part. So it is dividing into two parts, but two partitions, because I told you it is a divide and conquer algorithm. It is dividing into two parts. Now you see the partition algorithm. In partition, you are passing the array A and then your low and high are the two index. The low is the lower index that will be assigned as for the pivot elements key and taken I equal to lower +1, j equal to high because it will go up to the end of the array, and check the loop. The loop will be keep on running until I less than j. Every element, left side element should be less than the key. Your key is your pivot. And if less, then I will be incremented to next. This is keep on running. How long it will run? Until a of I is less than a of key. That means if the data is less than pivot, the I is keep on incrementing. Whenever the data is less, it is stopping the loop. Then it will go to right side. Once you come to right side, it will check whether right side data is greater than the pivot or not. If a of j is greater than key, then j will be decrementing because j comes from right side. So j is decrementing. It is keep on running. How long? Until a of j is greater than key. Then once the left means first part and right part both are over, then it will check whether I is less than j or not. If I is less than j, that means one round is over. Then it will swap the corresponding elements a of I and a of j. After swapping, then it is keep on going to the next round. It is keep on checking whether I is less than j or not. If at all I is less than j, that means I has crossed j, then will come out. That time the pivot element and jth element will be swapped. So this is swapping after the complete round. Then again it is calling the Quicksort with two times again. A of low with j-1, a of j+1. Then swapping. How to swap? P equal to a of I, a of I equal to a of j, and a of j equal to p. That is the general swapping algorithm. This is the way the swapping occurs. Please observe a small example here. I have taken some 13 elements. 1, 2, 3, 4 up to 13. The values are 38, 8, 16, 6, 79, 57, 24, 56, 2, 58, 58, 4, 70 and 45. Now, I have chosen the 38 as the pivot. Once chosen the pivot, then I will check because you have taken the left as a pivot. So, I will start from right first. Now, here there is a pointer called down. The down pointer is pointing to last position. Now 45 is greater than pivot. Okay, then come down because it is now the loop is keep on running. 70 is also less than pivot. Sorry, means greater than pivot. If the data is greater, because right side data should be always greater. If it is keep on greater, then it is keep on down. So down is coming down. Now it is coming to 11th position. In the 11th position, the value is 4. But 4 is not greater than 38. So stop. That means the right side loop is stopping now. Once right side loop, then come to left side loop. Here, while coming to left, what it will do? It will check whether left side data is less or not. Now, 8 is less than 38. Yes. If it is less, continue. 16 is less than 38. Yes. Then 6 is less than 38. Yes. Then come to 79. When you come to 79, 79 is less than 38. No. So stop it. So up is stopped here. Already down is stopped here. Down stopped at 11th position and up stopped at 5th position. This 5th and 11th they will be swapping. These two will be swapped. After swapping, my data has come like this. 4 has come to this place and 79 has come to this place. After first round, then come to second round again. Because it has to continue how long? Until the down has crossing up. Down has crossing the up. So again checks. 79 is greater. Then pivot. Pivot is how much here? 38. So always check the pivot value. Pivot value. 79 is greater. Then 58 is greater. But 2 is not greater than pivot. So stop it. So when 2 is not greater, the down has stopped here. That means from right side you have gone. Then come to left side. When you come to left side, you have to check whether the data is less or not. 4 is less than pivot. But 57 is not less. So stop it. So up has stopped here. So now the 57 and 2, it will be swapping. It will be swapping. So after swapping, 2 has come to this place and 57 has come to this place. But still, up is coming up and down is coming down. Whenever both are crossing each other, then time it will be swapping the pivot element with the down. So till now, it is in the middle only. It is still in the inner loop. Then again, 57 is greater than pivot. 56 is greater than pivot. When 24 comes, 24 is not greater than pivot. Stop it. So down has stopped here. That right side is over. Now come to left side. When you come to left side, 2 is less than pivot. 24 is less than pivot. 56 is no. So stop it. So pivot has. So now up and down has crossed each other. So when it's crossing each other, wherever the down is there, that value, how much now? Your 24 and your pivot is how much? 38. These two will be swapping. So after swapping, the 38 has come to this place. 38 has come to this place and 24 has gone to the pivot position. So now that means after one round, 38 come to the correct place after sorting. Means once the data is sorted, 38 will be in this position. In this position. So now it has divided into again two parts. So this is one part. Because I told you it is divide and conquer policy. So this is another part. It is keep on going like this. So this way you can do the quicksort. Similarly, the remaining elements, because again for the remaining element, same process. You can continue. You can observe here how pivot and up is coming down. Because every partition again divided into 2. So because it is following divide and conquer policy. You can observe here how up and down are crossing each other. Whenever down is crossing, that time the pivot element will come to the perfect place in the position of the sorting array. So like this, you can observe here how it is going also. Similar right part. You can choose one of the element 56 as pivot. Then compare right side. The right side data is always greater and left side data is always small. So while checking, if the data is greater, keep on going. Whenever it is deviating the policy, stop there. Again come to left side. Similarly, while coming from left side, if data is less, keep on going. Whenever it is deviating the rule, stop it. That time, up and down, data we have to swap. Whenever down has crossed the up, that time the down element will be swapped with pivot element. So this process will continue until end. So after that, you will get the corresponding array. Okay, this is the value. So this is the way the sorting works. You can see as another example also. There are number of ways to pick the pivot element. You can choose either 40 as a pivot or 100 also pivot. After finding the pivot, it will choose the correct position After finding the correct position, it will divide into two parts. Okay. You can choose here like this. 100 is pivot. Then it will find the data. Pivot, it will checking right side data. If the right side data is greater than 100, then the up arrow is coming down. And if the left side data is greater, the I is keep on moving up. Here I kept I and J. I is pointing to low and J is pointing to high. So this is a simple example of this. So you can put like this. While A of I is less than pivot, I is incrementing. If A of J is greater than pivot, it is J is decrementing. So you can see how the data is moving from one place to other place. Whenever both the loops are over, then it will check whether I is less than J or not. If I is less than J, then A of I and A of J will be swapping. So this is the way whenever I and J cross each other, that time the pivot element and Jth element will be swapping. Okay. So this is the way the quicksort works. Finally, you can observe here how the data is moving from one place to other place. So finally, the 40 has come to the correct place. So once the 40 has come to correct place, that time you can observe here the left side data is always smaller than this and right side data is always greater than this. So this is the final data for the 40. And the time complexity in 3 cases you can observe. The best case is order of n log n, because n time it is partitioning and for every partition it takes log n time. So the total time complexity is order of n log n. Similarly, worst case, whenever the data is already sorted, that comes under the worst case. So that time it is like a linear array sorting. So that means n into n time. So that is order of n square. Similarly, in the average case, that is order of n log n. So the best case and average case are almost same. Where in the worst case, the time complexity is order of n square. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.